The objective of today's dissection is to examine the interior and exterior structures of the eyeball. First of all, let's examine the anterior structures of the eye, which can be seen through the open eyelid. Here we're able to see the fibrous coatings of the eye, consisting of a transparent cornea at the front and an opaque sclera behind. Notice that the transition between the cornea and the sclera, there is a mucous membrane, which is the conjunctiva, a well-vascularized mucous membrane that helps protect the eyeball from infection. Here we're able to see the cut edge of the conjunctiva that would normally be continuous to line the interior surface of the eyelid. Notice that the cornea is not as transparent as in a living animal, and you should understand the reasons why this is turned to be as milky color. Turn the eye over to be able to examine the posterior aspects. Normally, this part of the eye would be hidden from view because it is embedded in extraocular fat, some of which you can see adhering to the posterior aspect of the eye. Notice also that there's a pinkish ring of skeletal muscle. These are the 6 extraocular eye muscles that move the eye around within the orbit. We can't tell which extraocular eye muscle belongs to which, because that would be determined based on which eye, whether it's left or right, and the origin of the muscles from the back of the bony orbit. We're also able to see that right in the middle of the posterior part of the eyeball is the optic nerve. The optic nerve has a thin sleeve of dura because this is part of the central nervous system. And when you pick up the edge of the dura, as shown here with the forceps, you're able to see that it is continuous with the fibrous coating of the eye, the sclera. When you reflect back the edge of the dura, you'll be able to see that there's a very thin space between the dura and the optic nerve itself, and this is the subarachnoid space filled with cerebral spinal fluid. Within the middle of the optic nerve are the myelinated axons of retinal ganglion cells that transmit visual information from the neural retina, the inner coating of the eye, to the rest of the central nervous system, the superior colliculus, and the lateral geniculate nucleus of the thalamus. Now let's examine the interior structures of the eye. To reveal the interior structures of the eye, hold the eye so that the front of the eye is on the right and the back of the eye is on the left, and insert the sharp scalpel in the equator of the eye halfway between the anterior and posterior surfaces. You'll notice that as soon as the incision is made with the scalpel, that some watery fluid exits through the incision. That fluid is aqueous humor, the watery fluid that occupies the front portion of the interior of the eye. Using the sharp tines of the scissors, insert the scissors into the incision and make a cut completely around the equator of the eye to divide the eye into anterior and posterior halves. You will notice bits of the gelatinous vitreous humor adherent to anterior eye structures, and you can remove some of that with the forceps. You'll notice that the front of the eye contains the lens, which is immediately behind the pupil. You're able to see through the lens the margin of the iris that defines the pupil. Using your forceps, you can reach in and remove the transparent lens from the anterior eye structures. Take the lens and put it onto a written page, and you're able to see that the convex surface of the lens gives rise to a magnification, or a positive diopters, in order to magnify the image. Once the lens has been removed, look at the pigmented part of the eye. This is very darkly pigmented, and it may be difficult to see the margin of the pupil, which is the iris. This is the vascular coating of the eye, as well as a tufted area at the base of the iris, which is called the ciliary body. The ciliary body produces the aqueous humor that travels through the open pupil and is drained through veins that are found in the anterior chamber of the eye in front of the iris. The other purpose of the ciliary body is to put tension on the lens and regulate the size of the lens to focus for far and near in the process of accommodation. Now turn your attention to the posterior aspect of the interior of the eyeball, and you will notice that there is a gelatinous fluid in the posterior aspect of the eye, the vitreous humor. You can remove the vitreous humor with the forceps, and that will reveal the interior of the eye. You're able to see at the very back of the eye the retina with the blood vessels coming out of the middle of the optic nerve head where the axons of retinal ganglion cells enter. These blood vessels are seen with an ophthalmoscope, and they supply nutrients and oxygen to the nervous coating of the eyeball, the retina. You can take your forceps and lift the retina, the neural retina, from the underlying pigmented vascular layer, the choroid. Moving the retina away from its association with the pigmented epithelium and the choroid would be a retinal detachment. In this eye, unlike the human eye, you're able to see that the choroid pigmented layer is divided into a light absorptive black area along the horizon, as well as a shiny green pigmented layer which is reflective. This is called the tapetum and reflects light back into the eye of animals who are usually active during the night. So now you should be prepared to do a dissection of the eye and reveal both the exterior and interior features of the eyeball that allow us to be able to see.